Decorator object-oriented design pattern, and I'm gonna start with the generic UML diagram of this pattern. So what is the UML diagram of the decorator pattern? Initially, I'll just show the diagram and then come back and discuss it later on. So this is a generic UML diagram of the decorator pattern, and essentially what we want to do is we want to extend the functionality of a certain class. I called it here concrete A, and we don't want to extend its functionality by extending from it. We want to extend its functionality by delegation, so not by inheritance but by delegation. And essentially this is what the decorator pattern does. It allows us to extend the functionality of a class by delegation and not by inheritance. And so I'll come back and discuss this some more. And for now, let me go ahead and show an example of the decorator pattern. So what is an example where the decorator pattern is used? And so an example where this is the case is in enterprise Java beans. In EJBs, we have the EJB object, and that's essentially an example where the decorator pattern is used. And I'll explain how it's used and shortly. Okay. So let me, before doing both explaining the example and explaining the generic UML diagram of the decorator pattern, let me go ahead and kind of define the pattern, what it does. So what are the characteristics of the decorator object-oriented design pattern? So this pattern is also known as the wrapper pattern. So the decorator pattern is also known as the wrapper pattern. What it does is essentially it provides an alternative to extending class functionality by inheritance. It essentially allows the extension of class functionality by delegation instead of inheritance. Okay. And it essentially dynamically adds or removes functionality to an object, and it operates transparently to the... Okay, let's go ahead and discuss the example. So okay, so what is, in this example, what's my concrete remote interface and my session bean? Let's discuss those. So essentially, when we do EJBs, if it's a session bean, we have the bean that we create. It has to implement the javax.ejb.sessionBean interface, and same if it's an entity bean, it has to implement javax.ejb.entityBean, and if it's a message-driven bean, it has to implement javax.ejb.message-driven-bean. So in this case, I took a session bean, so it has the same name as this guy, my session bean. Okay, and so when we write an EJB, we need to write a bean, and we need to write a remote, and if it has a remote client view only, we need to have a remote interface and the home interface in addition to the XML deployment descriptor and the context objects. So what we're concerned about here is the bean itself in addition to the remote interface. So we're supposing we have a remote client view, so we would need a remote interface. And by the way, this would be the home interface. Okay. So this would be the remote interface, and the remote interface extends from javax.ejb.ejb object Okay, so let's go back now to the decorator pattern. So we're talking about these two guys, about this remote interface and about this bean. Okay, so so essentially when we write those, the bean and the remote interface, when we uh, so what the EJB container does with those is that it's gonna wrap the session bean with its own object, and we call it an EJB object. So I called it here an EJB object decorator. And by the way this is implemented is probably different between different application servers. But in any case, uh, the other thing that I wanted to mention here is that in this example, I wrote here imaginary for the my session bean, and the reason it's imaginary is it implements it does not implement the my concrete remote interface, so it does not implement the interface, the remote interface. So the bean does not implement the remote interface, but it has to implement, so it's a requirement in EJBs that it has to implement all the methods that are in that interface. So business method 1 and business method 2, they're gonna be in the bean class since they are in my concrete remote interface. Okay. And the reason it does not implement the interface is that if we have a remote interface, the method are gonna be able to throw remote exceptions, but we have to handle two cases in EJBs. We have to handle remote client view and local client view, and in the case of local client view, remote exceptions are not thrown. So that's one of the reasons why the bean does not implement the remote interface. Okay. And we're talking here, all what we're talking is an EJB 2.1 and before. After EJB 2.1, EJB changed completely. So anyway, so okay, so let's come back to the example. So the EJB decorator that I have here is gonna essentially wrap the bean itself. So it's gonna wrap this session bean, and so if a call is made to one of the business method in the decorator, like business method 1 or business method 2, what the EJB decorator is going to do is it's going to route the call, so there would be inside those business method the ability to call the bean, the my session bean, and when we instantiate the EJB object decorator, it's going to have an instance of the session bean that it stores inside it. Okay. And then it allows it to call method on the session bean. Okay. In addition to those methods, we have additional methods which we call decorator method, and in essence, what EJB does, it's going to add to the bean security, transactions, and other services, and so the ability to wrap the code that the developer writes with a decorator, it enables the EJB container to provide that bean with all those services, security, transactions, and other EJB services. Okay. Okay, let's go ahead and now go back to the generic decorator pattern and discuss this generic UML diagram of the decorator pattern. Okay. So essentially, the decorator pattern is a structural pattern. So it's one of the structural patterns, and what it adds, it adds functionality to a class at runtime. So what it does is that it adds functionality to a class at runtime, where subclassing is gonna result in a huge amount of new classes. Okay. So we're gonna get a big increase in new classes if we go with subclassing. So we go with delegation with a decorator pattern. Okay. So let's go ahead and discuss it. So we said this guy is the class that we want to extend its functionality by delegation. And the way we do that is we go ahead and extend this class from from an abstract class, or we make it implement an interface. In this case, we made it extend an abstract class, so we made it extend abstract A, and then we create a decorator class, so I called it here Decorator A, that also extends from that abstract class. Or if in the case that this abstract class is an interface, so Decorator A would also implement that interface. So one thing to note is in the example that I just showed of where the decorator pattern, where a variation of the decorator pattern is implemented, we had the bean class did not implement the interface, but it had all the methods of the interface. So I showed it here. I said I labeled it as imaginary, since it does, in essence, it does implement that interface. Okay. So anyway, so as a requirement of the decorator pattern is that it has to extend the abstract class or implement that interface. Okay. So we have so now we have decorator A. So okay, so abstract A, what it's gonna have is it's gonna have all the methods that are in concrete A. So here we have operation 1 and operation 2 are the same operation 1 and operation 2 that are in concrete A. Okay. And the decorator class is gonna have a reference to abstract A. Okay, but that reference in essence is going to contain a concrete, since this is an abstract class. Abstract A is an abstract class, so in essence it's going to contain a concrete A instance. Okay, and it's going to be passed to it when we instantiate it. So decorator A, we pass it an abstract A class, which would be actually an instance of concrete A. Okay, and we would have the same methods. So operation 1 and operation 2. Now we also extend from decorator A, and we extended concrete decorator A. So decorator A could be also an abstract class, okay? And concrete decorator A is going to have the actual functionality. In the case of the example, I did not put an abstract class in between, but so it depends on how an application server implements it, and in this case I just didn't put it in between. But in any case, so we have the concrete decorator A that is gonna essentially have all the methods of concrete A, and in addition to those methods, so in addition plus, it's gonna have additional decorator methods. Okay, so essentially, if a call comes into operation 1 in concrete decorator A, it's gonna go ahead and use the instance that's passed here and delegate that call to the appropriate method in concrete A. So if it's to operation 1, it's going to delegate it to operation 1. If it's to operation 2, it's going to delegate it to operation 2 in concrete A. Okay, and we would have any additional functionality that we wanted initially to implement, to add to concrete A, we would add it to concrete decorator A, and this is in essence extending the functionality of concrete A by delegation instead of by, so this would be by inheritance if we did inheritance, but we are not going to do that, so we're going to extend it by delegation. And